So who saw who went and did the lockpick thing today? The lockpick booth over there in the conference room. Anybody go check that out? Practice lockpicking. It's one of the cooler booths I've probably seen at a conference. Definitely interesting perspective on taking that physical security aspect and letting you come play with like lockpicking. Holds a special place in my heart specifically too. I have a background that deals a lot with that type of physical security and type of background. I'm gonna tell you a little bit about myself. I was originally in the military, joined right out of high school. I served in the Army from 2007 to 2018. I was not originally a cyber or application security person by trade in my early career. I joined in as infantry. I ended up going in 2010, went to Special Forces selection and became a Special Forces. I ended up doing about 5 years, many tours to Iraq, Afghanistan, even a little bit of time in Africa. One of the biggest questions I always get is, okay, so how'd you get to AppSec? Like, where was the transition there? One of the coolest things about that type of background is everything that applies to learning how to do those jobs really well applies to application security. It's a very security-minded profession. You're constantly having to be aware of different threats and how to handle them and how to approach them. And you're also a very technical skills, especially with what I was doing as a medic. Everything was based in algorithms. Everything was based in processes. How do I act and react within a space? And how do I move forward to reduce the amount of damage that's being done or can be done? So it actually translates extremely well into the realm of application security. When I first left the military, I went and actually became a developer. And I spent a couple of years writing software for Lockheed Martin. It was a great experience. I learned a ton there. And I was able to also, at that same time, I transitioned to the National Guard. And I currently serve as the Senior Cyber Network Defender for the North Carolina National Guard. As you might notice, I have a lot of IAC certifications. That was attributed to the fact that I transitioned into the National Guard and they funded my training to allow me to get that amazing education. So I've taken that education from GIAC and SANS and learning all that security, and I took that experience of being a developer and I got the opportunity to go start with an amazing startup security journey as an application security engineer. That's currently where I work, and I'm right now the content lead for the application security team for Security Journey. So today I'm here to talk about the software security testing lifecycle, the framework that testers need. The big thing here is one of the projects I took on recently, not recently, but a little while ago, was we want to create content that was geared towards application security testers, not just developers. And we want to look at how should we approach application security testing. And I did what I think everybody does when we start getting into this field. I start reaching out to all the different OWASP projects. I start reading the OWASP Top 10, Mass VS, the security testing guides, start consuming all that content, start talking to different professionals out in the field, spending a lot of time on Twitter, debating what the right things and wrong things were to do. And in the end, one way I work in my process is I put a lot of information up on a whiteboard and I try to make it make sense. And I start trying to move things around. And something we noticed as we kept trying to build this content was there wasn't a good organized way for us to transition from the beginning of when we were first creating software to the end that was specific for application security testers. So what we did is we created our own approach to it. And we started taking, now not every individual idea in here is original. These are all different things we apply in different places, but we try to organize it and structure it in a way that makes sense for how I approach the software development lifecycle, the secure development lifecycle as an application security tester. And what I should be doing at each phase that allows me to focus in on the things I actually have to test and be much more proactive and refined into the actual things that are for my application. So the idea is we're no longer trying to shotgun and get something from a great individual scanning tool and react to it, but I make a much more proactive plan to security testing that builds from each phase to the next. All right, so we call it the software security testing lifecycle, and like any good word, we have to have a great acronym. And our favorite acronym for this is SWISTLE, just rolls off the tongue. So SWISTLE is what I'll refer to it from now on. And basically, it's exactly everything I just said. Integrate security, it's not meant to replace anything. It's meant to supplement. And what it does is we're trying to look through the eyes of a security tester through each phase of the security development lifecycle so that we're more proactive and that we are focusing our testing on what needs to be tested. Another big thing is why another framework? There are tons of frameworks out there, especially that we have guides that say why the security testing guide. One of the biggest things that we saw a problem is a lot of these guides were for like a QA team, right? It's not someone that's just focused on security testing. They're doing smoke tests, they're doing integration tests, they're doing UX tests. It's all these different type of testing they're doing, and they're not necessarily focused on security. And most of the time, even when you look at a secure development lifecycle, the testing for security testing's 4 phases down the pipeline. And all of a sudden our software is developed, we're testing, and all of a sudden we have these alerts that say we have problems we have to fix, and we're throwing it back to the devs to fix to them, right? So that's not a proactive, that's a completely reactive approach to security testing. So the hope is to get ahead of that and to do it focused on security and separate security from quality assurance, because they're not the same. Your security tests are not necessarily checking the quality or functionality, they're checking the security of products. So our guides and our approach to it need to be different. Who's Swistal for? So I got 3 categories. Primary, everybody's gonna think is our security testers, our developers, right? Those are the 2 people that have their hands most on the product, right? We also have something we call product adjacent. And what we call product adjacent is anyone that places their hand or has an influence on how I'm developing my product. They need to understand it at a base level if this is something you adopt. And the reason being is you need to understand why I'm doing what I'm doing during each phases and what I expect you to be doing during those phases to support my tasks. So this isn't just for developers. This isn't just for your security team. It's also so that anyone that lays their hand on their product, or if these are the things you're going to adopt, they need to understand how this works so they understand what you're going to be doing and how they can support you in this process. So like any good framework, we have a flow diagram. So, and we start out with, we're going to go a deep dive in each one of these different phases, but a quick overall is the first thing you need to do is we're going to talk about security requirements, because that's where all software development starts, is knowing what your requirements are. We're going to dive into threat modeling, building a security testing strategy, talk about actually doing security unit tests and doing a review process. We're going to talk about automation testing, which is a huge part of security testing. And then finally, we're going to do what I call validating security findings and controls. A lot of the places you're going to see that called like your penetration testing, or when you get behind the keyboard and actually do something. But we separate this out because we're not doing pen testing in this traditional sense. I'm not going to I'm not hiring an outside pen tester to come in and try to break my product. We're going to make a focused attempt to test things that we know we have to test for based off our security testing strategy from the things we identified in our threat model that we know we have to test. So it's a much more focused, proactive way to go about that manual hands-on testing. All right, the first thing, knowing our security requirements. This isn't an overly complex concept. The big thing here is I need to know my product and what we consider security requirements if I'm going to test for it. As a tester, I shouldn't be coming at the phase where like, hey, we've built our product, the security team did the threat model, now it's your turn to test now that the product's done. The security professionals to be at the very beginning. And now I also want to caveat that the security tester isn't always just an individual role at the company. If I'm on a 10-man team at a small startup company, my security tester might also be my developer. When I talk about this, I need to understand when I say security tester, I'm just saying whoever's wearing that hat at that moment. So if I'm the developer who's also doing my security testing, when I talk about what you should be doing at these phases, this is the time for you to put that security hat on your head and be like, okay, as a security tester, this is what I need to be doing at this phase. The 3 type of requirements we need to understand is your business requirements. There are your external requirements and your internal security requirements. So external security requirements are basically things like your laws and regulations that apply to your application. If I handle health information, I need to handle data differently than if I'm a gaming application, right? I need to know what laws and regulations apply with me. If my product is being used overseas, I need to understand possibly what EU regulations are going to be applied to my product. And as a tester, I need to know these things so I can validate that we're putting in the appropriate security controls to stick to those security regulations. Business requirements are things that are going to make me lose business. I'm going to lose customers. It may not be a legal requirement, But if we leak PII on our platform, we may not be legally held accountable for some of that information. However, there's a good chance if I have security-oriented people and I'm a security platform, I'm not going to use your product again. I'm security-oriented. You lose me once, you're probably not going to get me back. And then internal security requirements. Those are things that we're talking about is basically based on your company's policy and your ethos and the things that you hold true to, like as a requirement that as a company, these are things we're going to protect and do. They might not be regulated, they might not lose customers, but the way we decide that we want to handle ourselves, these are security requirements that are going to be in all of our products. As a security professional, if you do not understand your requirements you'll be testing against, you cannot be an effective tester. Because something you might find that you're like, oh, that's not a big deal as a security alert, might be a big deal based on your company's security requirements. Now this one's a big part, and I'm gonna probably stay here in a minute, and we're actually gonna talk about each phase of this. Threat modeling. Huge into threat modeling. So you cannot test an application, or let me rephrase that, you can, but I don't think you can do it effectively until you've taken time to sit down and look at how the application works, the different parts of that application and how data flows. Now, as a security tester, you may not be the one making the decisions of what security controls are getting put in place to mitigate different threats during threat modeling. However, you should understand what threats are facing your application, and you should know what security controls were put into place so that you can appropriately test that those security controls are working effectively. So the first step, we talk about scope. Understand the scope of the application. So what am I testing? What am I testing for? Understand the different impacts of the different security controls that have been picked. It's basically understanding when I test, it's not just, oh, I'm going to test against our source code, right? Oh, by the way, we also have 10 different packages and dependencies we've included in our application. I need to make sure that I'm running my software composition analysis tools, that I'm actually checking to make sure that we haven't included other vulnerabilities from exterior products. Understanding what I'm responsible for testing at the beginning of this process is extremely important so that you don't leave gaps. Next thing you do in threat modeling is you draw. We're going to sit down and we're going to put all the different components of our application and we're going to draw how the data flows. How many people are pretty familiar with threat modeling? I've gone through this process. All right, security conference. I'm pretty sure like that's a pretty integral part of a lot of what we do. Now I'm going to go through things you guys probably already understand from the threat modeling process. And like my entire intent is to understand that we need also, how am I looking at this as the tester? What am I doing during threat modeling as the tester? Here, having the tester involved in part of drawing out your threat model, and when we talk about the next phase, which is applying things like stride, how I'm doing, and I'm actually looking at the different parts of my applications and threat and face, it's great having your tester there, especially if it's a separate role, because this is somebody that's gained experience by testing our applications and said, actually, to be honest, I find this all the time, right? If you're not the actual security tester and you're someone that's actually running one of these programs and you have application testers, you should bring them in on this process because they have a very unique perspective and experience from doing their testing where they're going to see stuff that your developers or your architects might not see. So they should be involved in the threat modeling process. So applying stride. This is like the big part for what the security tester really needs to pay attention to. And that's understanding that we found these different threats in our application. We've identified the different type of areas that we have security controls we've put in place to prevent different threats. So as a security tester, I need to identify two things. One, that there's a potential threat there. And then two, that we've used this security control to stop it. So it's something like we have a SQLi potential threat because we have a login interface that goes back to the database and retrieves data, right? So we put in input validation, we used an ORM, and we put multi-layer security controls in place. So as a security tester, understand that we have to test for SQLi because we use an SQL database. Understand that I need to test to make sure our input validation is working correctly. And I need to go in and test to make sure that I can't retrieve things improperly with my ORM. Because anyone knows how an ORM works, just because I have an ORM doesn't mean I've used it right? I can make an SQL statement inside my ORM and still have an SQL vulnerability in there. So now that I've identified these controls and this vulnerability, I know that I'm going to have to test to ensure they're working properly later on. All right. So, and this is exactly what I kind of stepped into that ahead of time, right? Once we apply the mitigations, that's when you're applying your security controls. So this is the phase where I'm identifying what security controls we've used, whether it's authentication, authorization, separated privileges, what have we done to mitigate those vulnerabilities we saw, then we have to test the work properly. The most important part of threat modeling is we didn't just draw a happy diagram and draw in some security controls and then hand it to the dev team and say, go build. As a security tester, the next step of what we're calling Swistle is I'm going to build my security testing strategy. And what I'm going to do is, with my understanding of my security requirements, having participated in threat modeling, so now I truly understand my application and I know what security controls we've implemented, I'm going to take that documentation from threat modeling, I'm going to build a thorough security testing strategy from that. And that's security testing strategy is going to dictate how I do my security unit tests, and how I'm going to do my automation tests, and how I'm going to do my manual tests. So the security testing strategy is a pretty vague term, and it says exactly what it's supposed to be. But just to understand that what the entire intent within Swistle, when we call about the security testing strategy, is very specific. It's a document that we've used, that we've created from our threat model to dictate how we're going to test our security controls and our validation tests when we get security alerts. So there's about 5 steps that we need to look into here. The first thing is we need to review our scope, understand what we're testing. We're going to go through the data flow diagram, which is when we sit there and actually drew out the entire documentation of what interfaces we need to test. We're going to define security tests based on the identified threats. Let me rephrase that. We're going to define security tests based on 2 different things. You have the threats that you identified and the security controls you've implemented. And the reason we're separating out those 2 is because there's some threats that are really hard to test for or to build security controls for. One might be a good example is DOM cross-site scripting, right? You can do input sanitation. You can do sanitation on your input, especially if you're reflecting any sort of input from the user back onto your website. Now, first of all, just don't do it. That's the easiest way to prevent that. However, if you have some requirement where you're just choosing to do that in your application, the security controls can be difficult to implement. So that might be something that on the back end, you just need to ensure that you're testing that vulnerability isn't there. Now, automation testing has a really hard time picking up like things like cross-site scripting. That's something that's way easier to find if you go in and you manually test for. So when we identify these different things and we come up with a testing strategy, I understand that my automation test probably won't pick up on all of my possible DOM cross-site scripting vulnerabilities. But when we created our data flow diagram, I saw that we were going to have to reflect the message back to the user. Cutting in and out here.
Yeah, it's working for the recording, sorry.
All right, that's cool. We'll keep doing it this way then. Where was I? All right. So this is the point where we're going to identify things that are going to be easier to pick up during using tools and automation. And then there's other things we're going to have to do manual validation to identify and ensure that we've prevented those vulnerabilities. Last phase, you got to select correct people, processes, and technology. So when we're building out a security testing strategy, the first thing we do is we look at that data flow diagram. I understand my different threats and the different mitigations I implemented, right? So here we have identified threat number 1, and that's getting user data from the SQL database. And I know it might be possible to SQLi. So we put validation and ORM in there. On our next page, we're going to talk about building the actual security testing strategy. And the way we want to approach this is pretty specific. We want to identify the threat that we're mitigating. We want to identify the security control that we use to mitigate that. And then we got to identify what in our entire testing process we're going to do to validate that that threat has been mitigated and that the security control is working properly. And the approach to this is like in the first one, I have an SQLi. Well, I'm going to conduct server-side input validation. Keyword server-side, not client-side. For my testing strategy, the first thing I want to do is I'm going to write a unit test to confirm that input validation security control is working properly. I'm going to dive into this a little bit later. There's a big difference between what I call a security unit test and a functional unit test. Functional unit test is the one that makes all my lights go green and bright because I made sure the happy path worked, and I'm like, hey, 100% coverage. I'm a go, right? Security unit test is when I actually get creative and I take the unhappy path and I started creating scenarios where I attack my application using security unit tests to ensure my security controls are doing what they're supposed to do, prevent attacks. Now, another thing I got here, use Wapiti and a fuzzer as a test automation to ensure I don't have SQLite. And if you guys don't know what Wapiti is, that's a open source project that's a vulnerability scanner. One of the big things I'll talk about in automation is you have to customize your automation tools. I remember the first time I used Wapiti just to get familiar with it, I went and scanned it against my application, like it didn't find nothing. I know this application is vulnerable because I built it in. Well, it's because I didn't customize the tool. I didn't set it up properly to actually give me good feedback. So understanding the tools you're using and how to use them properly is massive. You can't just be doing check the block security unit testing, right? Or check the block security scanning. You have to customize your automation tools to work properly or you're not going to get actionable feedback. The last thing I'm going to do here is I might do a part of my penetration tests on my interface. I might use a tool like SQL Mapper to attempt to exploit a SQL vulnerability, right? Now, you don't have to build this many layers of steps, but my entire process here I want to explain is I've added tests to each phase of my last 3 phases, right? When I'm developing my software and building unit tests, I'm building security unit tests. That's one phase of testing. My second phase of testing is that during test automation, I'm using scanning tools to identify these type of vulnerabilities. And then at the very end, when I do my manual testing, I'm using my actual threat model to test the things I already know should be working and or as a threat. So I'm not just giving it to a pen tester to go figure out, hey, just black box or what's the right term for that? Go test my application without knowing anything behind the scenes. Right. So black box testing. So the entire intent there is like, I know what's supposed to work there, right? And a lot of people say that's not a good thing. Well, to be honest, it's a good thing because I know I need a test. I know what security controls I have. And I know I need a break. Now, black box testing has its time and place. That's not this. This is how do I get software out to the customer in a quick manner while hitting all my testing proper check blocks. All right, so that's the general concept here. We want to identify a threat, we want to identify our security controls, and then talk about by each phase how we're going to test that individual piece of software. All right, phase 4 on the software security testing lifecycle. This is build tests and review. So build tests is when we're talking about building our security unit tests and something else I call fuzz targets. And I highly recommend fuzzing. Now, a traditional way that people see fuzzing is in 2 ways, right? Like, hey, only people who have C++ fuzz. Who else fuzzes, right? That's one response I get a lot. And the other response I get a lot is, well, fuzzing is what the pen tester does. He finds the interface, he runs a tool and just jams a bunch of data in there and hope he gets a response. There's actually amazing projects out there that support fuzzing and automation. And it can be done really well if you do it properly. And to do it properly, one of the big things we talk about is setting up fuzz targets. So fuzz targets are a way of telling an automated fuzzing tool exactly where and how I want them to fuzz in my application. So there are tools out there that will allow you to just like run a fuzzer against every single interface in your application with all sorts of random data. And once you start, it'll probably be done in 5 or 6 days, right? So that's where fuzz targets come into play, and I'll talk about that a little more in a second. The other part is security testing review. As developers, we've gotten amazingly good at knowing that I can't push code into my main project until somebody else looks at it, right? Are we good? All right. So, all right. So as developers, we've gotten really good at knowing that we can't just push code right into the main project and be like, oh, it'll be cool. Like, I'm good. Like, I know what I'm doing. I don't have to worry about it. we do a peer review, right? I put it up there, I put someone on to review it, either a peer or a senior developer goes through and make sure I'm not doing something crazy or that I'm not adding a vulnerability. At least somebody's checking my code before I inject it into our main branch. As security testers, we don't really do that, right? We come up with our own security testing strategy and then we implement it. Now, if you're part of a big team, you might have that senior security testers that come up to you and be like, all right, no, what you're doing is like wrong, you need to change things. But we don't have a really formalized process like we do with pushing code. I think that's something that we've really been missing with our testing strategy. So during this phase, when we're starting to get the developers to build our security unit tests, it's kind of that check on my sanity with a peer tester and or a senior tester to ensure that I'm doing something properly. And the things they're going to be looking at is, am I selecting the right tools and processes? Are there things that I'm missing, that they might have experience for missing? And this is a great time to share information within your project. So say that you're working with one team, and I've worked in teams like this, where we've had our entire internal team. We had 3 developers, a quality assessment, a security tester, and our UX person. That was our team. But another team might be also building software, and you have a security unit, a security tester that's seeing vulnerabilities pop up that you haven't even been looking for or thinking about. This is the time to share that type of information and do that knowledge share with the people in your company so that we're getting that better coverage. All right, so the 2 things that we're talking about, and I've touched on these a couple of times. The security unit tests are really important. And when we do these, we need to be very creative about the way that we do it. And I'm gonna go through a couple quick code examples just to make sure I drive home the difference between a functional unit test and a security unit test. The other thing is the fuzz targets. And the fuzz targets are important so that we can conduct fuzzing on our projects while saving times and being focused on the things that actually need to be fuzzed. All right, so the first, I'm gonna caveat right off the bat, I used Ruby for my code example. And I don't know how readable that is. But I chose Ruby for 2 reasons. 1, I write code in Ruby. And 2, it's pretty straightforward, I think, in reading what it does. Right now here, I have a function where I'm creating a user account. And before I create my user account, I'm doing input validation on the username and password to make sure they follow my company's policy. But pretty simple. My security control here is input validation before I'm allowing a user to create that account. Functional unit test, when I test this out, I'm gonna go in and I'm gonna be like, all right, I'm gonna create a new account. And when I create that new account, given a username, user, and a test password 123, horrible password, don't use it, just for the example. But I put in my, that's something typical a dev would put in there, right? Do I meet the basic criteria when I put in there, put in some random data, and then say, like, all right, let's create the account. And I expect it to create the account and come back true. And it works, comes back true, an easy test. Now I've got my test coverage now been checked to block, I can move on to my next function, right? What we've missed here though, even if you start doing some edge cases where you put some random data in there, and where I go too long or too short, what we're not doing is we're not approaching this from an actual attacker perspective. We're not taking that moment to think, how would someone try to break my security control to do something malicious in my application? Now, not everyone that builds, most of the time, the security unit tests or your unit tests are being built by your developers. To be honest, this might be a moment to take that thing that everybody loves to do, because everybody loves to write unit tests, right? Like, it's the favorite thing for devs, like all day. This gets a chance to make you a little more entertaining. Like take that moment and like, hey, let's step out of our developer box and be like, how would you break your application and that security control you put in place? And start thinking like that attacker and start having a little more fun with it rather than, and that gets you out of that like, that check the block kind of like mindset. It gets you into that like, did you write that well enough that you can't break it? Right? Can you break your own security control? It's kind of a challenge in its own way. Not everyone's going to adopt it. It is a way to try to get the people more engaged and actually increase the security testing earlier on in the process. Because unless you're doing these, you're not security testing at this point. You're going to do security testing after the fact. Right now is the time to really get the developers to really assess how they built those security controls and test to make sure they're working appropriately. So here's an example of a security unit test. Now this is a very simple example, right? So I'm taking that same thing and I'm gonna pass in a simple SQL injection. No spam, okay. And like it's simple, it's 1 or 1 equals 1, right? Simple thing. It should always return true. If it returns true, I'll get back more data than I expect. Now, this should return false. My test passed, my security control works. Doing one simple injection attack isn't the right answer to this, though, right? That's a very linear way to test this. One of the better ways you can do is you could have a whole group of tests, or they can call on a file that has a whole list of SQLI that run against it in one simple unit test, right? So be a little more willing to think out of the box of how an attacker, because an attacker's not going to try one type of SQLI and oh, it didn't work, next one. Like, no, they're going to use a tool that's going to cram a bunch of data in there. Absolutely. So, I mean, so SQL Map, Burp, I'm a big open source guy, so I haven't really ventured too far out of those because I haven't found a scenario where I've needed to. Yep. All right, fuzz targets. A little more detail on this. So the new age fuzzing they actually have is some stuff that's actually smart fuzzing. And what it does is rather than just jamming a bunch of, like when you fuzz, you're trying to accomplish 3 things, right? I either want the program to stall, crash, or have some unexpected result, right? I'm trying to cause something weird to happen, and then I have to try to figure out what happened on the after fact. A lot of the new ways to do it, who here's heard of IAST, right? IAST tools. So, so interactive application security testing, right? So that's where when we build our application, they put instrumentation in the application to be able to watch data flow. When you run a DAS tool against it, and now you can get, instead of the traditional DAS where I attack it and I have to wait for feedback, I can actually see what's happening under the hood of my application. Well, they actually have come out with a lot of new smart fuzzers, like AFL Fuzz Plus, I think, does this. LibFuzz, I think, is instrumented to do this also, where you can actually build your application with instrumentation and then start fuzzing it. And what it does is it not only does the fuzzing where you're still attempting to crash or cause some sort of unexpected outcome, but the agents on the inside of the application can see what points you hit and why. And so when it does that, it gives feedback to your fuzzing tool, and then it'll take the piece of data used to cause that incident, and it'll continue to manipulate based off that piece of data. And what that does is it allows it to be much more focused on how it attacks your application. And it takes a way less time than just starting with 1s to 0s to massive amounts of characters to photos. It's a much more focused way of doing fuzzing. Now, the way fuzzing targets help with that automation process to make it even faster is that I can basically a fuzzing target wraps around an interface and says, hey, I want you to fuzz here, and this thing only takes images. And so let's start with images and start fuzzing with you manipulating the way this image is formatted, going in here and the type of images you use to fuzz that target. Or this takes string input. Let's try to jam an image input in it, but let's start with a basic string input and start manipulating the way you fuzz from there. It gives you a much more focused way to start, and it allows you to be able to fuzz the places you identified during your threat model that need to be fuzzed and nowhere else, and then be systematic about what data you're using to fuzz it, so you're reducing the amount of time while getting good feedback from that fuzzing tool. All right, the other thing we talked about was the tester peer review. I kind of touched on this a little bit, so we're going to kind of fly through this. The big things you want to see is they're going to want to look at your threat model, your testing strategy, what tools you picked for automation, the different type of pen testing approaches you decided based on interfaces, and the other big thing is you do the exchange of information. So I got ahead of myself earlier and kind of talked through this slide with all big points, especially the big last one is that exchange of information I think is really important within the testing community, because especially with people in your organization, this is the moment to start that conversation of what you guys are seeing and what is the most important to be focusing on and adding to your testing. All right, so automate testing. This is phase 5. When we think of any SDLC or SDL, this is when we finally see testing show up in our testing pipeline, right? So this is when we have our testing automation tools. This is our dynamic application security testing, our IAST tools and fuzzing. One of the most important parts with Swistal that we try to emphasize here is that I don't just throw a automated testing tool up on the platform and just let it run without doing any customization for my application. And I customize it for my application based on having gone through the process of my threat model and knowing what's in my applications, the components that need to be tested, knowing what type of database I'm running in the background, knowing what type of processes that are going on so that I can customize my DAS tool to run effectively against my application. It seems like a simple thing, but if you don't take the time to actually do it and customize it, you're not going to get good results, or you're going to get a ton of false positives. And the biggest thing we want to do here during our automated testing is reduce the amount of false positives we get. Because in Swistal, the next phase we're talking about, and when we actually go in and do our manual testing, is going to be driven off of two things. It'll be driven off our threat model, and it's going to be driven off the results we get from our automated testing. So what traditionally happens is we run our automated testing, we get a bunch of security alerts, and they're either 1s, 2s, or 3s on severities. Some might be false positives, some might not. And until we get into this big process of, all right, well, let's look through now and see, let's customize it. Now we have these alerts and identify what's false positives. If we had customized it in the beginning, we would have a much smaller workload to start with. But the worst thing you can possibly do is get a printout of all these security alerts and then throw that sheet back over to the devs and be like, hey, I got a list of stuff for you to fix. Because they're going to love you for that. And about the third false positive that they're trying to fix for you, they're never going to listen to you again. So that's like one of the biggest things we want to like take away from this is we want to make sure we do very focused automated testing based on what our application actually has in it so that we reduce our false positives. And then we're, as the testers ourselves, we need to go in and validate what's actually a false or positive security alert so that we can give good feedback to the developers to do remediation. Biggest things to take away, automation is huge. It's going to save time. It's going to create consistency. It needs to be customized for your application. There's tons of open source projects out there. Zap's a great project as long as you like customize it well. Wapiti is a great project out there. I think we brought up Burp. Burp isn't completely open source. Like it's definitely it's on the cheaper side though, and definitely worth its weight in gold. So there's a lot of projects out there. The biggest takeaway is if you're not doing some sort of automated scan right now, go get an open source project, throw it in your pipeline, and start. Right. Like just start the process and then start customizing it for your application.
What was that third one?
Burp. Wapiti, Zap, and Burp were the three I talked about. Wapiti. Yeah, it used to be called Elk. I don't know if you guys remember the old Elk scanner. And ironically, Wapiti is a type of Elk. It's like Wapiti 3 now, I think is the version they're on. All right, phase 6. This is everyone's favorite. This is like hands-on keyboard time. This is like, I'm a pen tester, I get to break my application time. And like, so this is the stuff that everyone loves. However, the biggest thing that a lot of people do here is like, cool, it's time for me to go pen test. And then I get out my pad of paper and I just start trying to break stuff and I start writing notes. When we do this, we want to do our validating, what I call validating security findings and controls very strategically. And it's specific to what I just said. My security findings are what I'm validating. So that's coming off my automated tests, right? Those are the alerts I've received. Now I'm going to validate they're actually security problems. And then I'm going to validate my security controls. And these are the security controls I identified in threat modeling that need to be manually validated or should be manually validated to make sure they're working properly, that automation may not test well enough and or should just be tested. First thing you want to do is you want to identify the threat and vulnerability. And this is what I was talking about here. It's coming from our DAS, SAST, IAST tools, as well as coming from our threat model. And we put in our security testing strategy and saying we're going to validate those security controls during pen testing. So as you guys are starting to probably see, the entire premise of Swiss, nothing in here is some unique, crazy idea that people aren't already doing in pieces and parts. It's how do we put it all together so it feeds into a well-formed process. I understand my security controls. That allows me to do good threat modeling, which is going to feed into how I'm going to build my security testing strategy. Now that I have a good security testing strategy, I know how to set up my automating testing. And now at the final end, I can do a good focused penetration test against my application based on the feedback I got from my automation tools and the threats I identified in mitigation. The idea is it cascades and it feeds into each other in a systematic approach, so security testers are staying engaged at each phase of development. Understand the vulnerability. I cannot emphasize this enough. So this does not mean that when I check SQLI, I Google once, see the top 5 ways that I know that you can do an SQL vulnerability, and I call it done once I test those. You need to understand how that vulnerability actually works. When I test access control, I need to know how the actual security control we put in place works so I can test against it. Once again, just go like one of the great places, OWASP testing guide. Amazing place to go check out how to test those individual vulnerabilities for those specific threats. Choosing the proper tools and techniques. So this is very specific to how I'm going to go about this. Like, for example, my DOM cross-site scripting. There's not a really good tool to validate that. There's a few of them that try, but there's not. To be honest, I need to go to the interface. I need to manipulate the data in a way that I know is going to reflect data back and cause a security alert. So then I can verify, okay, my security control is sanitizing that input and it's not an exploitable vulnerability. Other ones, tools will help. We'll be able to use Burp Suite as a interceptor or to be able to manipulate the data before it goes back to the server. So I can validate that we're not doing just input validation on the client side, but the input validations actually be done on the server side, right? So it's knowing the different ways that this exploit can be exploited and choosing the right tools to exploit it. Define the test objectives. This is really important because the next phase is the fun part. We just go in and actually do it, right? So we're setting up to this, right? But before I go in and just do it, I need to define my criteria of what is a passing test and failing test, right? I need to have a criteria before I go in. So saying that, okay, I think that the security control works because I've run X, Y, and Z, and I was unable to have this result, right? Have that clearly defined based on what you're trying to test. And then our favorite, exploit the vulnerability. We finally, after all this process and all this work, get to go break our code and show that either it's safe or it's not. The last step of this is we need to confirm those results. And it's not just confirm the results as in like, oh, I got a security alert box that popped up that I was able to get on my interface. Okay, you confirmed it. Now why? Why did that happen? So what was not done properly that allowed that to happen? Because it's not enough to confirm the security alert and then throw it over to the devs and say, hey, fix it. Do the research and figure out why that exploit actually happened. Why were you able to do that? Was it, and you're going to use that information to fix one of 3 things. So you're going to either have to refactor the code, right? Or you're going to have to update the security control because it's either in place improperly or obviously not doing what it's supposed to do, or you're going to have to implement a new security control because you missed putting one in the first place. So those are the 3 basic outcomes that you can come from finding a security alert. We either need to change the code, fix our security control, or add a new security control. And the idea is that we have a good base plan of how to fix the problem, not just the fact that we identified the problem. And then once we implement the final fix, validate the fix worked, and validate that you didn't introduce a new vulnerability while trying to fix the old one, especially if you're changing a security control. Like, oh, it didn't work this way, so I'm going to change the way it's set up and configured. Okay, well, now you have to go back in and do thorough testing of everything on that security control to make sure that you didn't break something else in the process of trying to fix it. So Swistle. Know your security requirements. It's going to allow you to do good threat modeling. It's going to help you build a very strategic testing strategy. It's going to allow you to customize your automation for your product, which is going to allow you to validate your security controls. Now, how do we adopt this? Depends on your application. Depends on your work environment. And if you're going to do anything at all, do the first 3 steps. Because you cannot protect what you don't understand. The first 3 steps of knowing what your security requirements are, doing a threat model, and building a strategy, if you can do nothing else, start there. Because at least at that point, you understand the threats that are facing your application and have a plan of how you're going to mitigate them. The idea is that this should be customizable for your environment. This might not work. If I'm a single dev with like 2 other people working on a small project, all these steps don't make sense. Take the concepts that make sense for your project and apply them. And that's what's going to happen in threat modeling. In threat modeling, those first 2 steps, I'm going to look at my application. You're like, we're not going to run automated tests because my application's like 2 pages long and it does a simple task, right? Identify what you need to do during threat modeling and customize this to fit your environment. This is not meant to replace the software development lifecycle or the secure development lifecycle. This is meant to supplement it. This is how do I, as a security tester, what am I supposed to do during each phase of this development cycle that's going to help increase the security of my application. DevOps or DevSecOps. I guess the security is implied, right? So DevOps, it fits DevOps too. Once again, you have to customize it to how your build pipeline makes sense. And when you do your threat modeling, you start implementing it, look at the different phases of DevOps and apply what makes sense. One of the biggest things to take away is take away the concepts of each phase and how they drive into the next and apply common sense to your project. Key takeaways. I'll let you guys read those as I kind of talk at the end here. Biggest thing is, like I said, no new novel crazy ideas for an individual task. It's just how are we putting them together in a way that makes sense to secure our application. If you guys have any questions of me, during the conference, I'll be over near my booth or security engineer booth right at the entryway. If you want to talk about application security, the software security testing lifecycle, if you want to talk about my previous military career, I'm a guy, I like to talk for hours. I'll chat with you. Come hang out with me, okay? So anyone at this point have any questions you want to ask me about Swistle or anything else? All right, the talk was that good. I love it. Also, feel free to reach out to me on Twitter at appsetguy_Mike or on LinkedIn, just a really long version of my whole name, Michael J. Birch. Love to have contacts, and I love to talk security, so feel free to reach out. Thank you guys, you were awesome.